And now we can go ahead and do the exercises, the homework exercises, to try to reinforce what we tried to learn in the lecture. I'm going to first do the odd numbered exercises because they have an answer key, so we could see if the answers that I give at least are corroborated by what was in the answer key. Then we'll just take a stab at the even numbered exercises, and anyone that disagrees, feel free to post in the comment section of the video. So, exercise number 27. Classify each of the following changes as physical or chemical. A, condensation of steam. Steam is made of H2O, which is water. Steam is the gaseous form of water. So condensation of steam is a physical change. And the answer key says it's physical. Burning of gasoline. Anytime we have burning, that's almost definitely, I know of no exceptions, is a chemical change. So the answer key says it is chemical. Souring of milk. So whenever a food substance is changed in taste, when there's something that has changed in its taste, souring involves the bacteria kind of doing something to the milk in terms of digesting it. So that's a chemical change. And the answer key says it is a chemical change. D, dissolving sugar in water. Earlier it said, I think it mentioned that in the lecture, that dissolving of something like sugar in water is, or something to that effect, is a physical change. And E, melting of gold. Whenever there's melting of a substance and it's still the same substance, like in this case, the element gold, it's just a phase change, what we call a phase change. That is a physical change. And the answer key says it is physical. Question 29. The volume of a sample of oxygen gas changed from 10 milliliters to 11 milliliters as the temperature change. Is this change, let me move this a little bit. Apologies to the readers, to the viewers here. I misaligned the browser window. It says, is this a chemical or physical change? A chemical or physical change? If it's still oxygen, when the volume changed, it's a physical change. It's not a chemical change. Then the answer key says it is a physical change. So let's look at question 31. Explain the difference between extensive properties and intensive properties. Extensive properties change in direct proportion to the quantity of the matter. For example, a cup of water versus a gallon of water have different extensive properties that are proportional to the amount. It's just as simple as that. Intensive properties are things like temperature, that it is invariant to it doesn't change with the amount of the quantity of the substance. So the temperature of a cup of water at 20 degrees has the same intensive property as a gallon of water at 20 degrees. And as I said in the lecture, entropy is an extensive property. A cup of water has less entropy than a gallon of water under the same standard temperatures and pressures, or standard conditions. So just note that. Entropy is an extensive property. Question 33, and let me just verify the answer key here. So question 31, it says their answer is the value of an extensive property depends on the amount of matter being considered, whereas the value of an intensive property is the same regardless of the amount of matter being considered. All right, so now question 33. The density D of a substance is an intensive property that is defined as the ratio of its mass. And again, apologies, I didn't set this up correctly. Let me, I'm adjusting the size of the window. So sincere apologies. All right, so now we actually see the whole question. The density D of a substance is an intensive property that is defined as the ratio of its mass, m, to its volume, v. And so here we have the formula, density equals mass divided by volume. And D equal, another way of saying it symbolically is D equals m divided by capital V. Considering that mass and volume are both extensive properties, explain why their ratio density is intensive. Okay, so if mass is an extensive property that is proportional to the quantity, and then V is also an extensive property that is proportional to the quantity of matter. So mass is directly proportional to the quantity of matter, and volume is directly proportional to the quantity of matter. We can kind of imagine then that we have, if we were just maybe a little bit more formal, that m equals something times quantity of matter. V equals something times quantity of matter. So you have quantity of matter divided by quantity of matter, that cancels out. And so then the dependence on the proportion of matter is removed. Now that's a long way of saying it. That's more of a kind of not really the most rigorous way. So for those who are really mathematically inclined, that may not seem sufficiently rigorous. And so if you don't like that question, I respect that. That's certainly nothing I would dock points on. I would just, if I were grading, I'd say just, I'd respect the effort in at least trying. So anyway, let's look at what the answer key had to say. The answer key says, for 33, being extensive properties, both mass and volume are directly proportional to the amount of substance under study. Dividing one extensive property by another will in effect cancel this dependence on amount, yielding a ratio that is independent of amount. And therefore, it's an intensive property. A ratio that is independent of amount, an intensive property. So now let's go into some uncharted territory here where I can't corroborate the even numbered answers. And I would invite the viewer to contest in the comment section if I said something wrong. So 26, classify the 6 underlined properties in the following paragraph as chemical or physical. Fluorine is a pale yellow gas. So that's underlined. Gas is a physical property that reacts with most substances. Reacts is a chemical property. The element melts at minus 220 degrees. So melt is a physical property, and boils at minus 188 degrees Celsius. Sorry, I should have said Celsius. Boiling is also a physical property. That relates to a physical property. The boiling point is a physical property. Finely divided metals burn in fluorine. So burn is relates to a chemical property. And by the way, the wording again is not extremely precise. It says classify the underlying properties. Sometimes when it says boils, boils at minus 188 degrees Celsius. Yeah, I guess I could say that's a property. All right, so I stand corrected. So anyway, metals burn in fluorine is a chemical property. 19 grams of fluorine will react with 1 gram of hydrogen. Anytime you see the word react, that is a chemical property. Classify each of the following changes as physical or chemical. Coal burning. Anytime you have burning, just it's safe to assume it's a chemical property. Ice melting, again, anything melting, safe to assume it is a physical property. Mixing chocolate syrup with milk. I would assume that is a physical change, not a chemical change. D, explosion of a firecracker. Anytime, again, that's a variety. That is a variation on burning, so that is a chemical change. An explosion is a variation of burning. Magnetizing of a screwdriver. That was covered in the lecture that magnetization is a physical change. Okay, number 30. A 2-liter volume of hydrogen gas combined with 1 liter of oxygen gas produce 2 liters of water vapor. Does oxygen undergo a chemical or physical change? Oxygen undergoes a chemical change because it is chemically changed with the hydrogen making water. So whenever you have two substances making another substance, that's a chemical change. So that's my answer anyway. Number 32, identify the following properties as either extensive or intensive. A, volume is extensive. Extensive. Volume, so a cup of water, again, this is particularly true, easy to see with liquids. A cup of water is different than a gallon of water. Volume is extensive. Temperature is intensive. Temperature is intensive, so a cup of water at standard temperature and pressure, and then you have a gallon of water at standard temperature and pressure have the same temperature, and temperature is intensive. Humidity is an intensive property, so the humidity of let's say it's at humidity is usually rated in percentage. So say the humidity is 50% in a small room and it's 50% in a big room. That means it's an intensive property. Heat. Heat, that's kind of an unfortunate term. Some of the real formalists in statistical mechanics and thermodynamics would not call it heat. They would call it internal energy. That's in terms of the molecular movements in the substance, but I guess heat is just as equivalent. So that is an extensive property. So one way to maybe kind of grasp this is if you have a cup of water, it might be able to, and you pour it over yourself, it may warm you up a little bit. But if you have 5 gallons of water at the same temperature and you pour it over yourself, it'll warm you up a lot more. And that's because the internal energy, or what they call heat, is dependent on the quantity. Now, that's a real subtlety. So I would just, if I'd been giving a lecture and I pointed that out, I would have to just say, okay, if it's in the lecture and it's in a question later, then it's fair game as a question. So I don't immediately recall if this, I think it was in the lecture that it said it. So E is a boiling point. Boiling point is intensive. So a cup of water will boil at the same temperature as a gallon of water, provided all other things are equal. And that's it. So that's it for the homework. of lecture 1.3. So thank you for joining us today. Take care and God bless you.